6.1 objectives. Write the augmented matrix for a linear system. Perform matrix row operations. Use matrices and Gaussian elimination to solve systems. And use matrices and Gauss-Jordan elimination to solve systems. Okay? All right, you ready? Okay, augmented matrix. Let me give you a system first. 2y minus z equals 7. X plus 2y plus z equals 17. And 2x minus 3y plus 2z equals negative 1. Okay, are you ready to write the augmented matrix? What do you think it's going to be? So 0, 2, 1, oh, negative 1, 7, 1, yes. So this is how we wrote them, right? In Algebra 2. Here's an augmented matrix. You ready? Okay, done. They just put a line in between the variables and the constants. Done. Do I need to do any more examples of that? Okay. Row operations. We did not do row operations in Algebra 2 because I taught you how to do substitution, graphing, and elimination, and then we did matrices, right? And we let the calculator do all of those for us because that was all that was required in our TEKS, okay? So I need to teach you about row operations, okay? So let's use this matrix. 3, 18, negative 12, and 21. And I'm going to write this as an augmented matrix. 1, 2, negative 3, and 5. Negative 2, negative 3, 4, and negative 6. Okay? Excuse me. The first thing we've got to do is know which one we're talking about. Okay? Are you okay with this? Us calling that row 1. And row 2. And row 4. No, I'm just teasing. That's 3. Okay? So the first thing it's going to ask you to do, this is what it's going to look like. What do you think we should do with row 1 and row 2? Yeah, swap them. So our new matrix looks like this. Think about what the answers to a matrix looks like, and tell me why do you think we would want to swap row 1 and row 2? Because it starts with a 1. Okay, think about what our answer looks like. What's right here? And our answer, isn't that a diagonal of 1s, right? All of these are zeros and all of these are zeros, right? And this is a diagonal of 1s. So we would start by getting a 1 right there. Does that make sense? Okay. Next, you're going to be asked to do something like this. That's a 1, I guess, with a hat on it. What if it asked you to do this instead? What would our answer look like? Now we're not going off the one we just did. We're going off the original matrix. Does that make sense? Okay, so what goes where? 1, 6, 7. Because what did we do? Yeah, we just divided them all by 3, right? And then what do I do with row 2 and row 3 if it doesn't tell me to do anything? Nothing. I just leave them alone, right? Just recopy them exactly as they are. God bless you. Does that make sense? Okay. Two times row 2 plus row 3. Tell me about row 1. Nothing, right? Nothing happens to it, so it's going to stay the same. Tell me about row 2. And adding it to row 3, right? But is it going where row 2 goes, or is it going where row 3 goes? 3. Okay, so what's happening with row 2? Nothing, right? Nothing. It's staying the same. Now, sometimes it'll tell you, put this for row 3, and sometimes you have to figure it out. Okay? If you have to figure it out, well, there's 2 choices that it could be, right? Try one. If it doesn't work, try the other one. I think you'll start to see a pattern. Okay? So what do we write for this one? Well, what's 2 times row 2? You guys mind if I write that down somewhere? Just to kind of help us out? So if I multiplied row 2 by 2, I would get 2, 4, -6, and 10, right? And then I have to add that to row 3. -2, -3, 4, and -6. That's just row 3, right? Okay. So when I add these two together, it's 0. When I add these two together, 1. When I add these two together, and row operations. How do you feel about row operations? Okay. I'm going to be very honest with you about this, about using matrices and Gaussian elimination and Gaussian Jordan elimination to solve systems. If I did not have to teach you this, I would not. Okay? Because we have matrices that we can use. We also have elimination and substitution that we can use. All which I think are easier than than solving it with these things, not with a calculator. Okay? So just go with me here. Okay? Here's the matrix that we're going to start with. Or the system, excuse me. 3x plus y plus 2z equals 31. X plus y plus 2z equals 19. X plus 3y plus 2z equals 25. Got it okay? All right. First things first. What's the matrix going to look like that we use? 3, 1, 2, 31, right? Okay. Okay. Everybody understand that? Okay. Think about what has to be right here. What has to be right here? Ones. And what has to be right here, 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 and here, here, here? 0. So we're going to make that happen. Okay? We're going to make that happen. The first thing that we're going to do is we're going to swap these two rows. So we're going to say row 1 swapped with row 2. Why would I put row 1 up there? It starts with a 1, right? Okay. So 1, 1, 2, 19. 3, 1, 2, 31. And 1, 3, 2, 25. Okay so far? Okay. -3, row 1, plus row 2. Notice where I wrote it. Where did I write this? In the second row. So guess which row is going to change values? Just the second row. Okay. Top row and the bottom row are going to stay the same. So is it okay if I go ahead and write those down for you? What am I trying to do by multiplying the top row by 3 and adding it to the second row? What's going to happen if I multiply the top row by -3 and add it to the second row? That first one's going to go to 0, right? Don't I need that? Okay. So the first row, if I multiplied it by -3, would be -3, -3, -6, and -57. Yeah? Now I want to add that to the second row. So -3 and +3, 0. -3 and 1, -2. -6 and 2, -4. -57 and +31. -26, right? Okay. Now, tell me what I need again. A diagonal of 1s and all the rest zeros, right? So this is good and this is good so far, right? What do you notice about everything in this row? It's all negative and it's all even, right? It's all divisible by 2. What if I divided this whole row by -2? Wouldn't that be a 1 right here? And isn't that what I need? So then we're going to say -1/2 row 2. And see how I'm writing it at row 2? So once again, row 1 and row 3 are not changing. But row 2 is. What is row 2 going to change to? 0, 1, 2, perfect, 13. All right, think about what I need. I need a diagonal of 1s, and I need zeros here and here and here. I tend to look at the diagonal of 1s and this bottom section first when I'm trying to get them to where they need to be. So the next thing I saw is that I want to make this go to 0 if I can, right? Well, if I add these two together, well, if I subtract them, wouldn't that give me a 0 right here? Top and bottom. So think about the numbers that are involved here. I want to try to stay away from negatives if I can. So should I say row 1 minus row 2 or 3, or should I say row 3 minus row 1? 3 minus 1. One, 1, 2, 19. 0, 1, 2, 13. So 3 minus 1. 0. 3 minus 1. 2. 3 minus 1. 0. 3 minus 1. Okay so far? So now what? I want this to be what? A 0? Okay. Well, if I multiply either of these two rows by 2 and add it, or -2 and add it to this bottom row, wouldn't that make it a 0? I don't want to multiply the top by a -2 because I already have a number here, right? I already have this 0. I don't want to add something to it. It's going to make it something else. So let's multiply the second row by 2 and subtract row 3 from it. Again, notice where I wrote it. That's going to be the row that gets replaced, right? So I have to multiply row 2 by 2. So that's going to be a 0, a 2, a 4, and a 26, right? And now subtract this minus this. 2 minus 2. 4 minus 0. 26 minus 6. 20. You okay so far? Think about what I need. I need a diagonal of 1s. I need 0s here and 0s here. So my 0s here are good, so I don't want to add anything together that would give me anything but 0s here, right? Is my diagonal of 1s good? No, but divide both sides, or not both sides. I need to divide this row by 4, don't I? So 1/4 times row 3. One, 1, 2, 19, 0, 1, 2, 13. If I'm multiplying the last row by 1/4, I get 0, 0, 1, 5. Now that's good for us, isn't it? Why is that good for us? Do I know what z is? What is z? 5. And so if we're using Gaussian elimination, we're done. Gaussian elimination, diagonal of 1s, these are 0s. Rewrite the system back into equation form. X plus y plus 2 equals, 2z equals 19. Y plus 2z equals 13. And z equals 5. Yeah? Gaussian, Jordan, all 1s, 0s, 0s, just like we talked about when we get our answer from the calculator. Okay? Tell me about these objectives.